Okay, so moving on, like we said, whenever there's only two conditions, we're going to use a t-test. Whenever there's more than two conditions, we're going to use an ANOVA. So if I ran a study and I wanted to look at whether studying words underwater versus on land produces better memory, I would, of course, use a t-test. Like we just talked about, you could of course have more than two conditions, and you could have more than two conditions of one independent variable. So the example we were just working with, maybe I compare high versus medium versus low something. Okay, that would of course again be reason to use an ANOVA. However, the other time we use it, well, actually there are times, but one other time where we use an ANOVA is when there's more than two groups, but there's also more than one independent variable. Okay. So if you remember back to factorial designs, remember we don't just have to have one independent variable, we can have more than one. So maybe I want to look at studying underwater versus on land, but also taking a memory test underwater versus on land. Okay. That would be a factorial design, and we're going to use an ANOVA for that. Okay. So just again, a reminder, if I had this 2x2 design of study location and test location, both being independent variables, remember 2x2 means I have two conditions here of this independent variable, and I also have two independent variables, this number and this number. Okay. So what this would look like is that I, of course, have every combination of those four, or rather of those two variables. So I would have some people study underwater, and then they take a test underwater. I would have some people study underwater and then take the test on land. And I would have some people study on land, take the test underwater. And lastly, some people study on land, test on land. Okay. Four conditions, 2x2. So whenever we have this, we're going to use an ANOVA. If I were just, say, looking at one independent variable of studying underwater versus on land, I would use a t-test. Again, if I was looking at people studying underwater versus on land, say on the beach, versus in an office, I would use an ANOVA. And also, if I have a factorial design, meaning more than one independent variable, I'm going to use an ANOVA. Okay. So we're not really going to go into this too much, like how to actually analyze for interactions and how to analyze factorial designs. Well, not fully anyways. We're just going to look at kind of how to eyeball them, how to tell what's going on, and just what the different outcomes can be when you have a factorial design, which you definitely have to know. And also make sure you know about writing a hypothesis for a factorial design, which we'll cover as well. So when you have more than one independent variable, you actually end up with three potential effects, or rather, well, actually, sorry, let me clarify. If you have a 2x2 design, you end up with three potential effects. Okay. Now, two of them are known as main effects. Right? And this just means that you're looking at the differences in the dependent variable and the condition means, but only as a function of one independent variable at a time. So I'm going to have a main effect of this first independent variable, and then I'm going to have a main effect of the second independent variable. And the key assumption here is that we're not going to be factoring in the other independent variable, whatever effects it might have. Okay. So we'll again, as always, look through examples of each of these. But yeah, main effects, again, we're just looking at what is the effect of this independent variable, ignoring the other one to some degree. And since we have two independent variables, we're actually going to have two different main effects. However, we're also going to want to know, is there what we call an interaction? An interaction means that the differences in the independent variable as a function of an independent variable depends on another variable. Or alternatively, how do they interact? How do they work together? How do they change each other? So if I wanted to know, does the effect of one independent variable depend on the other independent variable? That would be an interaction. Okay, so with our example, we're going to have people study underwater and study on land, and then we're going to either test them underwater or test on land. So we're obviously going to have these four conditions, like we said: study underwater, test underwater, study on land, test underwater, study underwater, test on land, study on land, test on. So here's an example of what we're looking at with the main effect. And by the way, when we run an ANOVA, it's actually going to tell us all three. We're actually going to have three different F ratios. Again, we're not going to go into this too much. That's, I think, upper level courses, but the F ratio is going to give us actually three different potential effects. So first one is going to be the main effect of study location. So did you study underwater or did you study on land? That's the first effect we're going to wonder about. And again, we're going to have three effects, or three potential effects rather, and they can all either occur or not occur if they're actually independent of one. Okay. So we're looking at the main effect of study location. Again, we're just comparing studying underwater versus studying on land. What we're going to do is we're going to basically ignore this other variable, testing underwater versus testing on land. So if we take our means here of the various conditions, we can kind of parse out the main effects from possible interactions. So that's all I've done here is, let's say these are the mean number of words recalled per condition. All right. So when they study underwater, if they take the test underwater, they score 6 on average. If they study on land, take the test underwater, they score 8 on average. Study underwater, test on land, 8 is the average, and then studying on land, testing on land is also, or is going to be 10 on average. Well, when you look at factorial design and analyze it, what you're really doing here is you're going to take different means of different combinations of conditions. So that's all I've done here. This 7 is, of course, the average of these two numbers. Okay? This 9 is the average of these two numbers. This 7 is the average of these two numbers, and this 9 is the average of these two numbers. Okay? So really what you're doing when you're running a factorial ANOVA is you're just looking separately at different means. So when I want to look at the main effective study location, what I'm concerned with is there an effect of studying underwater versus studying on land independent of being tested underwater or being tested on land? And all I need to do to get that is just compare these two. So compare the means. Basically, you're just going to collapse these two conditions and collapse these two conditions and then compare them. Okay? Or rather than collapse, let's say take the mean. So take the mean of these two, 7, versus the mean of these two, 9. Is there an effect? That should tell us, is there an effect of studying underwater versus studying on land? But again, since we're ignoring this other independent variable, that's why we're combining these two conditions or taking the mean. Okay? Just comparing the 7 versus 9. Without actually showing the p-values, does it look like there's an effect here? Yeah. seems to be an effect. I mean, we don't know without knowing the standard deviations and stuff like that, but just numerically, yes, collapse. Again, taking the means of these conditions, 9 definitely seems to be, or 9 is higher than 7. So that would suggest studying on land, again, ignoring where the test went, because we're combining those two conditions, taking the mean of those two conditions, is higher, is better, means you recall more words than if you study underwater. Okay. Actually, we'll come back to that. So again, that's the main effect of study type, just comparing the number of items recalled for studying underwater versus on land. You're averaging across the test conditions of underwater versus on land. Okay. How about the main effect of test location? Well, that's really the same logic, just for the other numbers. So if I wanted to know, the main effect of test location is going to be ignoring whether you studied underwater or studied on land. Is there an effect of testing underwater versus testing on land? So for that, I'm just going to combine these two conditions and compare them to the combination of these two conditions. Right? So the 6 combined with 8 is going to give us 7. 8 versus the 10, or 8 and the 10 are going to give us 9. So yeah, there seems to be an effect here as well. 7, obviously less than 9. So again, combining these conditions, combining these conditions, and then combining these conditions and comparing them, that's going to give us the main effect of test location. Okay. By the way, that's actually what we have here. So notice how you actually have both main effects going on at the same time. So you can have two, often you will have two different main effects. So notice here how, and this is probably easy to imagine, taking a test underwater is harder because collapsing across whether they studied underwater or on land, just taking a test underwater overall is harder. These two are lower than these two, right? Or the mean of these two is lower than the mean of these two. So testing underwater does seem harder. What about studying underwater? Well, that also seems to be harder, right? If we just compare the average of these two to the average of these two, it's again lower, suggesting that there's a main effect of study type, so study location. Studying underwater is harder, and testing underwater is also harder. Okay. Again, main effect of test location, you would be comparing the number of items recalled, the test being underwater versus on land, but averaged across study location. Okay. So this example we've been looking at so far is only showing main effects. So as a general rule, whenever you want to know if there's an interaction, meaning the effect of one independent variable depends on another independent variable, this is kind of a way to figure that out. So if I were to ask you, is it better to study on land? What's the answer there? Yeah, right, it is. So just looking at these two, again, whichever studying on land overall, when you combine the other conditions, is harder, right? These two, the average of these two dark bars is lower than the average of these two bars, the purple bars. So yeah, you can just give a straightforward main effect answer. Yes, it's harder to study on land. And also, is it better to test on land? Yeah, again, same thing, just comparing different means. So if I take the mean of these two compared to the mean of these two, same thing, right? There's obviously a main effect test location because testing on land results in more words recall. Okay. So this is an example of where there's main effects but no interaction. However, let's look at an interaction. So I probably haven't heard this before yet, but there's a classic finding in cognitive psych known as encoding specificity. And this is just the finding that where you, actually not necessarily where, but how you study should match how you take a test. Okay. There's limitations on it, like sitting in the same location in the same classroom doesn't necessarily matter. But if you were to test, say, or study underwater, you might be better off to take a test underwater. That's actually a real finding, and they have found that to be true. So if that's the case, if it's best to match where you study and where you test, you can kind of see how there's no longer simple main effects to talk about. If that's the case, if it's best to match where you study and where you test, well, then try answering this question again. Is it better to study on land? And is it better to to test on land? If this first statement is true, how do we answer these two questions? Well, we can't, actually. That's a trick question. Because there's not just main effects here, there's also interaction. So here's what that actually looks like. Let's put some actual numbers here. So say people got an average 10 when they study underwater and test underwater, 6 when they study on land, test underwater, 6 when they study underwater and test on land, and then 10 when they study on land and test on land, which these aren't the exact numbers, but that is actually what's been found. Well, it's kind of, again, we can't really answer the question. So let's try our usual comparison, or our comparison we used before of the main effects. Well, is it better to study underwater or on land? Well, taking the mean of these two conditions gives us 8, right? Taking the mean of these two conditions also gives us 8, right? So is it better to study underwater or study on land? Well, there's no answer there because they're the same. Also, is it better to test underwater, test on land? Again, the other main effect. Well, taking the average of 10 and 6 again gives us 8. 6 versus 10 gives us 8. There's not really an effect there. It's not better or worse to test on land. But there obviously is something going on here. The condition means are obviously different. So that's because it's an interaction. When you study underwater, it's best to take the test underwater. When you study on land, it's best to take the test on land. Okay? That's what we mean by interaction. The effect of one independent variable, studying underwater versus studying on land, depends on where you take the test. Do you take it underwater or take it on land? Because if you're taking the test underwater, you're best to study underwater. If you're taking the test on land, then it's better to study on land. That's what we mean by an interaction. Okay. So to revisit this question, the answer would be no to both of those, but it would be instead be it depends. Depends on, well, whichever way you want to phrase it, you could say it's only best to study on land if you're taking a test on land, and it's only better to test on land if you're studying on land, right? That's what we mean by interactions. So we mean that interaction is, again, the effect of one independent variable where you study depends on the other independent variable. Right? What was the effect of studying on land compared to underwater? Well, it depends on where you take the test. Okay. By the way, that's really all we're doing here with an ANOVA, is we're breaking it down by individual conditions rather than combining averages. So we're essentially gonna, there's a bit more to it than this, but we're gonna look, okay, technically that actually isn't what you do right away, but it is what you eventually do if the interaction is significant. You don't have to know this, you just have to kind of, again, know what an interaction is and describe it with words, not even with ANOVAs, but we're going to compare just these two and then just these two. Okay. By the way, here's what that looks like if you plot it out. So notice how conditions crisscross, right? By the way, this is also how you can spot an interaction. Anytime you plot things and it's not parallel, then you have, or probably have an interaction, right? So going back to this other example, notice how these two, the difference between these two is parallel with the difference between these two, okay? That's because there's no interaction, because there's only main effects here. You can kind of use that as a little trick. However, with this one, these lines are not parallel. Here it goes down, here it goes up. That means there's an interaction whenever the lines are not parallel. There's actually several types of interactions. This is just one. So an interaction is just any time the effect, again, the effect of one independent variable depends on another independent variable. For example, sometimes you only get an effect of an independent variable depending on another independent variable, rather than it crisscrossing. So here's an example for that. This doesn't make perfect sense, but I didn't want to introduce a whole new example since this one's so nice and simple. But just say hypothetically that testing underwater, or sorry, studying underwater is only better when you test underwater, like you see here. However, that's not the case when you test on land. So if you were to study underwater but test on land, that's not better than studying on land and testing on land. By testing underwater and studying underwater is better than studying on land. So again, notice how it depends, right? If I were to ask you, is it better to study underwater? What would you say here? Well, again, you'd say it depends, right? You'd say studying underwater is better, but only if you're testing underwater. Studying underwater is not better if you test on land. Then there's no difference. Right? That's another. Here's one more interaction. So this is where they crisscross. This is where it only occurs, the effect of one independent variable only occurs in certain conditions of another independent variable. This is kind of the other main one. The effect gets larger depending on another variable. So this would actually technically be a main effect and an interaction, but you don't need to remember that for sure. So what's going on here is that, yes, it's better to study underwater, but the difference is actually bigger when you test underwater. Studying underwater is better when you test on land, hypothetically, but not to the same degree as over here. That would be another interaction. Because the effect of this variable, studying underwater, depends on another variable. It's much larger over here than over here. Okay. By the way, again, we can use our rule for these other two. So are these lines parallel? No. These lines parallel? No. Okay. Just another thing, though, I want to be clear on is that main effects and interactions, when you test them, interactions can be misleading. When you have an interaction, rather, it can look like there's a main effect, but that's not necessarily the case. So let's go back to this example. Here you have an interaction. So again, studying underwater is better, but only when you test underwater. Studying underwater is no better or worse when you test on land. Well, using our previous calculation, this actually gives the impression like there's main effects going on. So let's look at that. If we take the average of these two, the 20 and the 6, we get 13. Average of these two is 6. Average of these two is 13, and average of these two is 6. Well, there appears to be two main effects going on here, but that's actually not the case, right? Judging this way, it looks like testing underwater is good, whereas, and also studying underwater is good. But that's not the case, because when we actually break it down by separate conditions and don't take the averages, we know that testing underwater, or rather studying underwater, is beneficial, but only when you test underwater. Okay? So that's why you just have to be cautious about, reporting a main effect when you have an interaction, because the interaction might make it look like there's a main effect that's actually only an interaction. It just occurred to me, one thing I forgot to mention is a totally different node. So when you have your F ratios, they follow the same logic as p-value. So the bigger an F ratio, the lower the p-value. Right? So bigger F ratio, lower p-value. Remember, a lower p-value means more evidence of effect or of a population difference. So don't forget that. Okay. I know things go back and forth a lot. Higher p-value, higher F ratio, higher t-value, more evidence of an effect, but higher F ratio, higher t-value also means lower p-value. Lower p-value is more evidence of it. Okay, so just one last thing on interactions. Remember, when we have just one independent variable, we phrase our hypothesis like this. Participants in condition A will score higher on independent variable than will participants in condition B. Or alternatively, participants in condition B will be more likely to do this behavior than will participants in condition A. So that's how it goes when you have only one independent variable. For example, if we were just looking at study location, not looking at test location, we didn't experiment on that, then it would obviously look like this. Participants in condition A, those who study on land, will recall more words than will participants in condition B, who study underwater. Okay. By the way, I meant to say earlier, that's kind of seems reasonable, right? Obviously, studying underwater could be distracting, and also taking the test underwater could be distracting. So if there were no such thing as encoding specificity and the match didn't matter, that might be what we predict, just a main effect of water. So studying underwater is bad and testing underwater is bad. But that's not what we get. We actually get the end. So, but our hypotheses are phrased a little bit differently when we have more than one independent variable, because we have to talk about the interaction. Okay. You should be talking about the main effects too, but especially talk about the interactions. Okay. So, but also kind of keep in mind that the main effect might be ambiguous because of the interaction. So, like we looked at here with this example, this gives the impression of a main effect, but it's really just the interaction. So, just make sure if you're making a hypothesis, you talk about the interaction. The main effects are more optional. It just depends on your research question. So when we have more than one independent variable, if we were to say, again, we're testing both where you study and where you test here, that studying on land will recall more words than those who study on water. Well, this is only a hypothesis for a main effect of study location. It's not saying anything about the interaction. So this is no good. If we have more than one independent variable, we need to talk about the interaction in our hypothesis. So we might instead say, well, we already covered this, but, or this, the design hopefully by now. Instead, that the effective study location depends on test location. That's a hypothesis for an interaction. More specifically, I would say participants, well, say that first part, the effective study location depends on test location. Participants who study underwater will recall more words if they test underwater, but not if they test on land. Participants who study on land will recall more words if they test on land, but not if they test underwater. That's a hypothesis for the interaction. So again, if you have more than one independent variable, make sure you're making your hypothesis about the interaction, not just the main effect or main effects plural. Okay. Couple review questions before we wrap up. So again, t-test is when you have two levels, 2 by 2, that's going to be an ANOVA. 1 factor, 3 levels, also one. Okay. Know if you have questions.